Hello, I'm going to say this in many different ways, different times, because I'm not sure when this actually goes live. So today we're doing times tables and making multiplication easy. We've got Shane Scott from Australia, who's a teacher, who is a published teacher. He's contributed to many textbooks, and also he's got many of his own articles provided, many of his own articles published. And the idea is that Shane's passion is about making maths real, how to bring maths in the classroom. He is a classroom teacher. He works in high school, secondary school, ages 11 to 18. And it's how to make maths real, how to make maths relevant, and wherever possible, easy. And today, times tables, how to establish confidence in multiplying, and also help to make the 1 to 10 times tables easy. So it seems to be working. Our live is working. Our connection to Australia is working. I'm going to pass over to you, Shane. I'm going to change the view. There we go. Over to you, Shane.
Hello, everyone. Welcome from a cold 13 degrees Celsius day in Sydney. That's about as cold as it gets down here, but we have to make do. Today, I'm going to talk about multiplication. And it's a bit of a strange thing nowadays because, you know, I regularly get the question of, well, why do I have to worry about multiplication? Because, I mean, let's face it, everyone's walking around with one of these now, and there's a calculator on it. And if you had something you had to multiply, you just push your buttons on your calculator and out comes the answer. And to a degree, that's absolutely fair enough. We have that technology, and I'm someone who is all for using it. But there's one thing a calculator can't do. Well, some calculators will do this, but definitely not on your phone. And it's nice that on a calculator you can go, what's 7 times 8? And hopefully you'll get 56. But the problem that the calculator can't do is say what multiplies together to give 56. Now, for secondary mathematics students, it's very important to know that, because when we look at topics in algebra such as factorizing, you need to know the factors of a number to work with it. And that's not what this is about today. Today we're looking at the junior years from grades 4 or 5 up to year 8, so late primary and early secondary. And I want to tackle the bane of...
What age, Shane, sorry, what age is
so we're talking about, you know, about age 9 to about age 14, but we can still go beyond that 14 too. And the bane of students and teachers and parents is knowing the times tables. Yes, you can always look them up, you can do them on a calculator, but the more that you're fluent with times tables, the easier it's going to make you do your maths. And the more your confidence is with that ability, you'll feel more receptive to further skills. Now, I want to start by telling you something that may shock a lot of people, because we're going to start by looking at the times tables. And in reality, that should be done by the English department, because times tables is not maths, it's English. It's processed in the same part of your brain that processes language, but we get them, so we have to deal with them. So what I want to look at is the times table. So let's start by looking at the times tables from 1 to 10. Now, in Australia, and I'm sure it's the same in England, you know, it's normally 1 to 12, and I'll get to 11 and 12 a little bit later. I just want to build 1 to 10. And what that really consists of is a block of 100 facts that you have to remember. And I say that a little bit tongue-in-cheek, because yes, you have to know it, you have to be able to use it, but some of these ones we can get away with. So let's look at it. I'm wondering now, I'm going to have a shot at sharing my screen just so you can see my timetable. So can you see my timetable grid there?
Yes, bright and clear.
Excellent. So that's what we have. And let's pull this apart a little bit to make life easy. So the very first row is 1 times. And we all know those answers. We don't even have to think. And the first column is also 1 times. So there goes 19 facts that I don't have to worry about because I'm very comfortable with that. Another thing that we can be a lot more comfortable with is the 2 times tables because it's doubling. And really when we're looking at numbers from 1 to 10, most people are comfortable with just doubling numbers. And then I'm going to go to the back end and let's look at these 10 times that are on the very bottom row and the very right column. And that's just a number with a 0 stuck behind it. So we can tend to be very comfortable with those 10 times tables. A nice one I like to throw in now is the 5 times tables. They just seem a little bit easier. There's nice tricks to it, like multiply by 10, which is easy to do, and then halve your answer. So you can get that degree of comfort with them relatively easy. And so what I've done is I've just color coded them there so you can see, well, we now have a lot less to worry about. And if you look at what's not colored in now, we've gone down from 100 facts that you have to remember to just 49. And then you can take out 1, 2, 3, 4, 5, 6, 7 more because they're those 5 times tables. So we're now down to 42 facts. Now, I'd like to jump to the 9 times tables because there's a way that we can deal with 9 times. And I have one way. Many people use their fingers, and I'm going to show you how to use your fingers to multiply by 9. And this is a great thing to do. Even when I'm teaching senior secondary students, 18-year-olds, not for the times tables, but for other things, there's nothing wrong with using your fingers to count. And, you know, lots of people frown on it and think, oh, that's baby maths. But you can make a great relationship using your fingers to nut out problems. So now we're going to use our fingers. So, Caroline, I'm going to ask you to give me a number from 1 to 9 that you would like me to multiply by 9 with.
7, please.
7. So I hold my hands up and I'm going to count 7 from left to right on my fingers. 1, 2, 3, 4, 5, 6, 7. And I'm going to drop that 7 finger. And you can see on my left that I've got 6. There's my 6. And on my right, I've got 3. And the answer happens to be 63. And that's always going to work for you. So let's reset, take another number. We might take 4 this time. So 1, 2, 3, 4. Drop that finger. And my answer is 36. So you can use your fingers to get those answers. And you do that for a little while and you'll start to see a pattern. Mathematics is all about patterns. And the more you see them, the easier it becomes for you. So let's take another number and I'm going to talk to you about the pattern. This is the way that I used for multiplication by 9 from when I was a young boy. And it's always stuck in my head. I think about it very quickly. So can I have another number, please, Caroline?
Sorry, had to unmute. 6.
6. So I think 6 and I take away 1 straight away. So my answer is going to be 50. 50 what? I need a number that when I add to the 5 makes 9, and that makes it 54. And that's the way I've always learned how to do times 9. So if I take, say, 8 times 9, take away 1 from the 8, I get 7. So it's 70. 70 what? 72. And that's worked for me, and until I've become so comfortable with it that I picked that up very quickly. So we can now drop the 9 times tables. Now, I know I'm saying that very easy, but that's not something that will happen overnight. That will be developed over lots of practice. But the thing is, while you're not getting the skill at the click of a finger, because you're getting the results at the click of a finger, the confidence is growing. And a lot of benefit to mathematics is students' confidence. The more they're confident, the more they're willing to listen and engage and understand what's happening. So let's now look at 3 and 4. There's a nice way I was told to learn your 3 and 4 times tables, because I'd like to say here that there is a good role to play with rote learning. I'm not a teacher who teaches by rote. I like to have understanding with my students, but I'm also aware that there's a time and a place where you've got to say, no, you just have to remember this. So the way to get these, and I'm going to use 3 as my example because the example's just as fitting for 4, is you start by just counting in 3s. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And do it. Do it a few times. Put aside 15 minutes and do it, every minute or so. And leave that. Just get that feel of what the numbers that we're dealing with 3 are. Just get used to that. And as you grow in your confidence, you can say those numbers quicker and quicker and quicker. The next step is to just extend your language a little bit. 1 times 3 is 3. 2 times 3 is 6. So you're building the association in your head that you start to know what these times tables are. And once you're very fluent and comfortable with it, you move to the next step, which is just getting some random multiplication times 3, and so getting them randomly. So using a piece of paper or an Excel spreadsheet to generate numbers, single digit numbers, but just getting those questions randomly instead of order. Your brain is used to the numbers that you're dealing with. So it's just a matter of getting that sorting happening. So it moves from your short-term memory into your long-term memory. And that takes practice. That'll take a while to get that down pat, but it's an important foundation for 3 and 4 that you must develop. Once that's done, you are only left with a core. I forgot I kept this going. With a core 9 facts that are. They're the 9 facts that there's no choice. You just have to drill yourself in. But one of the good things about this is, 6 times 6, 7 times 7, 8 times 8, they're the square numbers. So they tend to stay a little bit more. And then, if you're a bit of a science fiction freak like me, 42 is the magic number. So 7 6s, 42, and then we've got 48 and 56 to deal with. And you just have to practice that. I'm going to stop my sharing now. So now I should be back on video, which I thought I was for a while, but anyway. So you need to build up that knowledge, and it's a bit of a cheating way to get those 100 facts in there, but you must have it. It must be in long-term memory. It must be accessible. in some ways I consider myself a cheat because all I do all day, every day is maths. And so my mental arithmetic skills are very strong because I'm too lazy to get the calculator out of my pocket. And that's all I do. And that's why it stays with me so much. So that's the trick to build the foundation for your times tables. And I'm now going to talk in two different concepts. What I want to talk about, first of all, and both these are using the same thing that I made up as a teacher, is I made flashcards. So these are my debating flashcards. My son does debating, so he buys them as flashcards. So I got these, and I've put all my times tables on these cards, and I use them in my class. Now, as a teacher, I do something different to the way I would deal with it with a very small group or even an individual. So as a teacher, what I do is I've been to England twice, I've got to say, and one of the big things that I note is you guys love your game shows, and we have some of them as well. And a few years ago, there was this show called The Missing Link. The Weakest Link. My mistake. The Weakest Link. And one of the main premises of the show was the compere or host was very almost looked mean and didn't give much. And I play that with my class. So what I will do is I will get a whole row of students to stand up, and we'll start with the top card, and they've got to say the answer to that. And they've got to say the answer by the time I get it down to the table. And if they do, they're still in the game, and I'll go to the next student. And so we'll cycle through it. So I hold it up like that, and 6 sixes, and I'll give you a clue right now. On the back in light pen, I've written the answer. Yeah, I can do the answer, but it's very difficult holding this up, trying to see it in reverse and work it out to work out whether a student's got the correct answer. I've got a little bit of a twist to mine in that, let me find one, if I can pick it out. Here we go. I deliberately added the zeros in because 0 times 4 is 0, because I'd also like that awareness. And it catches students out, especially at the start, because they're thinking about their speed and they want to say 4, and I'll look at them with a deadpan face and say, sit down. And so we will do that. If they get a wrong answer, they sit down, and I'll tell them what the correct answer is. And we will go through row by row, and we will get a winner for each row. Then the winners of each row will stand at the front of the class, and we'll do the same thing. I'll do it a little bit faster as well, and we get the grand champion of the class. So even as parents, I'd recommend you buy a set of these cards. They're blank, and you just write it in with a felt pen. I was extremely lucky my wife wrote it because she's such a neater writer than what I am, and I was very grateful for her writing up 169 cards, because like here I'm showing you 3 times 9, but I've also got 9 times 3 in the stack. So all the times tables are there. And it's good, some kids get a freebie. They get a nice easy one like 7 times 1, and some other poor kid gets 12 12s. And that's the way the cookie crumbles. Now, I had a class quite a few years ago with only 4 students in it. And when I started, they were a bottom year 10 class, so about 15 years old. They'd struggled with maths all their lives, and they were functioning at about a year 6, 12 or 13-year-olds ability if they were lucky. And I started with these and another trick that I taught them, which I'm going to show you later. And the different way with these boys, because it was so small, we used a 30-second timer, an egg timer, and I also recorded how much they could do. And I will be honest, they complained to my head of department at the start, because they didn't like that I was doing childish maths with them, and they wanted to do the year 7 syllabus. But I stood my ground, and the head of department supported me as well. And to the point of just before I left, they were upset because I wasn't going to be there doing the times tables with them. And they went from getting about 5 correct in half an hour to 15 correct. So they tripled their score over a 3-month period. And that came by the practice and the drill of doing these times tables exercises. So if you're a parent with a child or a couple of children, or you've got a very small class, I would use that timer method, because then you can keep those results. And that would be great for things later on, like when you wanted to do statistics, all of a sudden you've got a batch of live data that you can use as well. So you can keep those scores. So that's what I used for that. That's my story on the base for times tables. And again, I like to emphasize, it's not something that will happen overnight, but it is something that I thoroughly recommend that you persevere with and develop that strong skill. And I'll talk about another trick that you can do as a parent, for example, helping your children with those times tables. So now I want to take a very big step, and I want to extend these times tables up to 20. So remember, this is given the fact that you are now comfortable with multiplying all your times tables from 1 to 10. When we look at multiplying up to 20, and most schools won't even touch this, and that's completely okay, although traditionally we do 11 and 12, there are 2 things that I want to separate. So one is multiplying a 2-digit number by a 1-digit number, and the other one is multiplying 2 double-digit numbers together, which will both be in their teens anyway. And both of them involve you holding a number in your head. And they're 2 slightly different principles. So here we go. I'm going to try and do this waving hands and using examples instead of using a whiteboard at school, but we'll work around that. So when we want to multiply a 2-digit number, a number in its teens, by a single-digit number, we break it up into 2 parts. So, for example, if I was to say 16 times 7, what I'm going to do is do what's 10 times 7 in my head, which is 70. I'm going to hold that number, and I'm going to do what's 6 times 7, which is 42. And so now I'm going to add 70 and 42. And that's going to be 112, 112. Now remember, when you're holding those 2 numbers in your head, you're really only going to add 1 set of digits together, because the units digit that comes from your times 10 will always be a 0. So you don't really have to worry about that. So if I take another example, 13 times 4. So I go 4 tens are 40, hold that in my head. 4 threes are 12. So I'm going to add 40 and 12 in my head. The units is okay, it's going to be 2 anyway. So 4 and 1 is 5. So the answer is 52. And so that now gives you 200 of the multiplications from the 20 times 20, 400 facts grid. So, if you say what's 5 times 16, or what's 16 times 5, I'm still going to work that out the same way. I'm going to have my 5 times 10 is 50. My 5 times 6 is 30. and I add them together and get 80. Now, because I happen to accidentally pick that number, sometimes there's other tricks as well. I mean, if I was to do 16 times 5, what I'm actually going to do is, if I use my hands as sort of a leveler, 16 times 5, if I half one and double the other, is the same as 80 times 8 times 10, which is 80. Now, some numbers lend themselves to those sorts of tricks. And when you're, when you're doing maths all day, every day, you get to have a feel of when you can apply them. But by all means, practice the teens multiplied by a single digit of holding and storing a number in your head, holding another one, and then adding them together. And that's something that will take practice. Now, the big one I want to talk about is what happens when we want to multiply two numbers together that are both in their teens, because it's not taught in school. And again, I'm going to say, if you've always got a phone, you can work it out on your phone, and that's great. There's no problem with that. And even with practice, it's nice to know, but I wouldn't be expecting someone to be able to, for example, factorize the answers that I'd get and know they were two numbers in their teens. But it's a nice skill to have. And again, I come back to, the more you build confidence, the more you build ability, the more you build receptiveness to what's happening. So let's take an example. I'm going to sort of talk it and use an example. So actually, I need to write it down, otherwise I'll forget what number I'm playing with. So I'm going to have, that 10 doesn't work. I'm going to have 17 times 13. There we go. 17 times 13. Okay. Now, it really does not matter which number we're going to pick to start with. So let's take 17. Now, this is a little bit tricky, but please bear with me. I take the 3 from my other number and just add it to 17. That's going to become 20.
Hold on, wait a minute. Just add it.
Yep, just add it. Add the 3 to the 17 and you get 20. And then I multiply it by 10. So that gives me the number 200. And that's what's staying in my head. Again, it's a number that ends in 0. 200 is in my head. The next thing I'm going to do is look at the units number of both of those, 3 and 7. And I'm going to multiply them together. So 3 7s are 21. And I'm going to add that to my original number. So my answer is 221. And that's all you do. So I'm going to put the challenge out there. I'm going to ask Caroline to give me 2 numbers in their teens that will multiply together.
Sounds like jiggery pokery to me. I'm going to say 17 and 18.
Okay, 17 and 18. Doesn't matter which one I do. So let's take 17 plus 8, and that's equal to 25. And I stick a 0 at the end. So in my head, I'm going to hold 250. The next question I have to ask is, what's 7 times 8? And this is where we come back to that importance of understanding the single digit times tables. 7 8s are 56. I'm going to add that to my original 250. And that means my answer is 306. And not a calculator was touched.
How? Why?
Okay, now you're asking a challenging question. If you're going to ask me why, that means I've got to pull out the algebra stick. And I'll be honest, I haven't prepared that either, and I'm not going to go there. And the reason I'm not going to go there is because we're targeting the 8 to 14-year-olds, I don't think it's appropriate to go into the algebra at this point in time.
Okay, so I'd like to challenge our 12 to 18-year-olds that might be watching, and adults, to work out the algebra. I'm going to put that challenge out there.
A 2-digit number can be written as AB, and if you separate it, it represents the number 10A plus B.
Okay, so that's not for everyone that's watching. That's only those that are comfortable doing the algebra. So we're just going to have to take Shane's on it, take it on trust at first. But then when you get to that point in your life, then you've got to prove it and send us a message to say, oh, I've got it. I finally got it. I understand why.
That'd be great. Okay, so again, this is something that takes practice. It needs two things. It needs that strong familiarity with the single digit times tables, and it needs that practice and patience of holding a number in your head and then adding a second number to it. But it's a little bit easy because you're not adding a true 2-digit number to a 2-digit number. There's only one digit you have to add and maybe throw in 100 here or there. So that's that one. So that's the main thing that I wanted to talk about with regarding mental multiplication. And again, if I have my way in schools, every student should be crash hot with their multiplication because it's such a foundation for everything. Yes, you can do things on your calculator or on your phone, but it just takes longer. And you need that little foundation work. It also mental arithmetic serves as a great checker when you're estimating. And those skills are very important. But there's two other things that I'd like to show you. And my son was shown this when he was very young. He was only about 7. And I love doing this at school because it looks like very difficult mathematics. And yet, once you know the secret, it's very easy. So I'm going to be nasty and put Caroline on the spot because she's the only person I've got here at the moment. And I'm going to ask Caroline some times tables questions, but don't panic. So I'm going to...
Hold on. My head was buried in the algebra there. Right, hold on. I'm with you again. I'd gone off. I was doing the algebra. It's quite nice because if you convert the numbers into A, B, C, D, 2 of those numbers are 1.
Yeah.
So that's nice. Go on. I'm ready.
So we're thinking about multiplying by 11. And so I'm going to give you some questions that you need to multiply by 11. So what's 3 times 11?
33. Easy peasy, lemon squeezy.
Nice and easy, isn't it? 7 times 11.
77.
All right. 12 times 11.
I do know that. 121, I think. No, it can't be. 12 times 11 can't be. 132. 132.
Yeah. What about 62 times 11?
Right. Now I'd be getting the pen and paper out.
Now that sounds really hard, doesn't it? And this is one of my most favorite things because students of any ability can actually get this answer out with no pen and paper, just using their brains.
Okay, so you've given me a bit of confidence here. Hold on. You've given me some confidence there. So thinking about it, it's 62 plus 620.
No, you're going the wrong way.
Ooh, Oh, okay, go for it.
Right? Because I want to show you this. I did pick this one deliberately, so I'm going to try and use my whiteboard because I think there was one of those. There we go. Share. Hopefully you can see my whiteboard now, and excuse the writing because I'm using the mouse. So let's look at 62 times 11. Now I'm going to rewrite 62 so you can see what's going on. 62. Okay, now the answer is just about there. Now I'm going to ask you a very simple question. What's 6 plus 2?
8.
And that's the answer.
What? Why?
Isn't that magic?
It is magic.
Yeah.
So but I mean, it's still 62 plus 620. That's not incorrect.
Absolutely correct. But isn't that easy to do it that way?
Yeah, I know, but it seems like magic.
So,
it seems like jiggery-pokery.
I know, doesn't it? It's super. Let's look at another number. I'm picking my numbers deliberately because there's a little problem. I'm going to teach you about the problem anyway. So let's look at not 53. Let's look at 45. So 45 times 11. So I'm going to do the same thing. You see, there's my 4 and there's my 5. And all I say is, what's 4 plus 5? It's 9, and there's my answer.
Okay, I can see why it's not jiggery-pokery at all. If you use my method of saying it's 45 plus 450, what are the two digits that are added together that are not 0? There's two digits that are added together where one of them isn't 0, and that is your key, isn't it? Yeah, okay. Yeah, I can see how.
And this works. And I'm going to do another special one. Let me just clear this. All right. So, and it doesn't have to stop there. Let's look at 11. So when I do 11 times 11, right, there's 1 there, and in the middle, 1 plus 1 is 2. Is that okay so far?
Yeah, that's what I was coming up with before, wasn't it? I was doing 11 times 11, not 11 times 12.
But
Yeah,
I
okay,
don't
ready?
have to stop here. I can take this number here, 121, and I can multiply that by 11. I stick 1 here, because that's that one. 1 plus 2 is 3. 2 plus 1 is 3. And the 1 goes at the end. So this number here is actually 11 squared. And this number here is 11 cubed. And why can I stop there? Let's do the same. 1 it goes at the end. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then my 1's at the end. So this becomes 11 to the power of 4. Which is exactly the same as 121 squared. Now, I want to tell you before I deal with the problem that I'm going to come up with on this is one of my favorite mathematical tricks. It's my favorite trick because I can walk into a classroom and I can have students throw 2-digit numbers at me and I can multiply them by 11 in my head faster than they can do it on a calculator. And they think that I am just magical because I can do that. And that's nice, but I want to give them something. I want to give them something from the classroom that they can race home to their parents and say, look what I can do. I can achieve this, something that sounds extremely hard, and yet they can do it. So what I need to do is look at the problem. Now, there's going to be a problem here. Let me make one up. Let's look at 75 times 11. So if we do what I've been saying, we'd stick a 7 here, and we'd stick a 5 here. And then we go, well, what's 7 plus 5? And what you want to say, well, that's 12. And you can't go 7, 12 to 5. There's no such thing. But that's okay. I keep the unit, so I put the unit.
No, I'm sorry, I have to stop you there. I have to stop you there, Shane.
And that
Shane, I want to be able to say 12 to 5. I think it's brilliant.
Oh, thank you.
Why can't we say 12 to 5?
Well, in some cases, we actually do that, but with the next unit across. Because like when you buy a car, you know, we talk about, oh, a car costs $5,300. We do that in its context. I don't think it's in our language to do that. And the reason being is because our number system, these are called the Hindu Arabic numbers, are based on place value. And when you want to say 12T, you're throwing out that place value. And so you're losing the power of our mathematical symbols. So what we do in this case is, yes, the 2 is going to stay there, but that 1 is going to bump up to 7. So it becomes 8. So my answer is 825. So let me do another one for some practice.
By interrupting you, Shane, I've actually forgotten what was it. 75 times 11. Was that what we were doing?
75 times 11. So let me
we're
write
still on
this
the 11
up.
times. Yeah, just checking because I'd forgotten. Yeah. It disappeared. Yeah, go on. Thank you.
So 97 times 11. So definitely the 7's going here. And I can see that I've got a problem already. I'm not even thinking about what that adding is. There's a problem there. So I know I've got to write 9 as the number 10. Knew that straight away. But then I go, all right, so what's 9 plus 7? It's 16. So the 6 goes there. And that's how I get my answer. Now, again, I want to say this. I'm going to go back to stop sharing so you can see me now. I want to say this. With that class of the students that struggled, I got them to do this. So I had an app on my phone. It doesn't work anymore because they didn't update it to go with the updates. And what I would do is I would generate a random 2-digit number, and they had to multiply it by 11 in their heads, one shot each. And it took them a while, but you know, these kids, 16-year-olds who have been bashed with maths for like 10 years, struggled all the time, are all of a sudden being able to do their times tables with some efficiency and to multiply largish 2-digit comfortable numbers by 11 in their head. And their confidence grew. And again, you know, it's such an important factor in a math class. You know, there's nothing wrong with giving wrong answers. You know, that's their learning opportunities, and there's nothing wrong with building up confidence. And that's the way I work in my classroom. Now, I did have another trick because I know we're getting close to an hour. So my other trick works on a different part of mathematics, which is patterns in mathematics. So I'm going to square some specially selected numbers. I haven't memorized the answers. I mean, you could say that you've just done that because there's only 10, but I'm going to get Caroline to give me a 2-digit number that ends in 5, and I will square it in my head. There's my hand so you can see I'm not using a calculator.
2-digit number that ends in 5, 7, no. 85.
85 is 7,225.
7,225. Okay, I've written it down. I'm ready.
Okay. Now, the easiest way to show you this one is to show you the table that I have made. I think you're that one. Share. Okay. The table that I made for the 2-digit numbers that end in 5. Can you see that table now?
Yes, nice and clearly, yes.
Excellent. Now let's look at the answers. If you look at the answers, every single answer ends in 25. So I knew half of my answer before you even said the number. I know it's going to be 25. But how do I get the other number? Well, you said 85. And now all I was listening to is, what was the first number that you said? It was 8. And I take 8 and I multiply it by the next number up. 8 times 9 is 72. So the answer is 7225. And if you look at this table here, any number, 3 times 4 is 12, it's 1225. So all I ever listened to was the first number you said and multiply it by the next number bigger than it. Works every time. It's only 10 numbers, that's fine. But all of a sudden, there's another little maths game that you could play that again builds that confidence. You know, you started off yourself, the kids are going, wow, you're such a freak, you can do these so fast. And then you give them the trick and they can go home and they can do it for themselves. Now, just because we're getting to the end, there is something that, I can do this. I'm going to stop share there. There is something very important and very helpful. I just want to grab another one. That parents can get. Now, I want to make this extremely clear. I am not a consultant for these people. There's no money for me involved at all. I just love this so much, and I think it's so beneficial. It picked my mental arithmetic up and improved it to a large degree. So there's a company called The Great Courses. That's their name up there, The Great Courses. I've got quite a few of their DVDs, but this is not one of them that I'm going to show you, but I'll put it up on the screen in a moment.
Jane, I've put a link in the description, in the comments below, that I have put a link so that you know just now in the comments below.
So this is a similar one about what I'm trying to sort of plug. This is by Arthur Benjamin. Arthur Benjamin is an amazing professor of maths. By all means, look up TED Talks and go to Math Magician, and you can see his skills in action, and you'll see that there's some of the tricks that I've picked up and used. I think I still have it on my screen. Yes, I do. I want to show it to you, so I've got to do my share thing first. Share screen. There we go. Share. So this is Arthur Benjamin's Secrets of Mental Mathematics. Now, the way that this company do their DVDs is that they cycle through sets of DVDs that they offer for a discount price. So you can see here the DVD normally sells for 220 Australian dollars. That's about 10 of your pound, just joking. And you can now get it right now for $40. which is something close to 20 of your pound in real talk. I can't tell you how many times I've watched those videos, but if you've got a student that's struggling with mathematics, I would strap them to a chair and force them to watch these videos, because if they give it a go, their skills will go through the roof. And if the skills do that, the confidence will do that, and the ability in mathematics will grow with it.
We've got people from all countries here, Shane. I know you're talking about the UK, but actually there are maybe 50% UK people in this group, and certainly YouTube, it's global. Now, what age group would you say to start using that mathematics?
Oh, look, I would use it from 7 or 8 onwards. It's got addition. One of the things that took me a little while to get used to is when you do addition on paper, we actually do it from right to left because of the algorithm that we use for addition, and that's perfectly okay. But the problem is, if you want to do it mentally, you actually have to do it the other way around. And it's a challenge because you've been drilled how to do it on paper, and all of a sudden you're being asked to do it in exactly the opposite way. And it takes a while to get out of that mindset. But the values in Dr. Arthur Benjamin's work is you get the hang of it and your skills will go through the roof. And again, not sponsored by them, nothing at all. I just really believe in that resource and think it's wonderful. And I think that's all the tricks I have for today. Oh, can we do a trick from Australia to Spain?
From Australia to Spain, absolutely, go for it.
Okay, so here we go. All right, so you got a calculator handy, and I want you to take 567.
Yeah.
And multiply it by any 3-digit number you like. I don't want to know.
Do I have to know what it is? Should I write it down?
No.
Well, I'm going to write it down in case you ask me what it is, because I won't remember.
I won't ask you.
Oh, okay. Multiply it by a 3-digit number.
And you should have an answer.
I have an answer.
Does your answer have 6 digits in it?
Yes.
Great. I want you to pick one of those digits that's not 0, and that will be your secret number.
Okay. Yeah.
Okay, now it's very clear because people are watching that I can't see your phone calculator there. I can't see the screen.
This is what Shane can see. You can see what Shane can see.
All right, so you've got your number. I would like you to tell me the other 5 numbers that are on display. You must tell me each of the 5, but in any order you like, it doesn't matter.
Okay, 59419.
Your number is 8.
Yes.
There you go. Bing, bing.
I'll just show you guys the number, just so that you... Okay, hold on. Oh, come on. Wait a minute. There you go. Up a bit. Oh, it's here. Sorry, wrong camera. There you go. There's the number. And I gave him all the digits except 8, and I had written down the number 8. There you go. And I gave him in a totally random order. Okay. But so if they get the multiplication DVD, a lot of these mysteries will be revealed.
I think that one is. He definitely does that trick on his TED Talk. I use it, and again, it's a great thing to practice because you're working on addition, and if you get lazy like me, you're working in modular 9 arithmetic, which is fine. But as a great line to start conversations with people. and you look like a freak in a
So
nice way.
what we want is our young people to actually learn how to do that, impress other people with it, and in the process they're doing lots of mental math. Woo!
Absolutely.
Go for that. Good job. Okay.
All right. Well, I think that's the end of my show for tonight. I hope you've enjoyed it. Please, for your students and your children, practicing the times tables is extremely important. Do not accept that you have a phone or a calculator. Yes, that you have, and they're great things to have. I'm all for them, but you still have to have that mental arithmetic ability with you, because you should see what I've seen, that students are willing to write for answers because they just have blind faith in their calculator and no alarm bells ringing. No, this doesn't sound right.
Fantastic. Thank you, Shane. And thank you for coming on our YouTube channel. We've got the one from last week, we didn't go live, so we'll be publishing that in the next couple of days. So thank you. If you're enjoying our lives, if you enjoy our YouTube channel, please subscribe, ding the notification bell so you know when we're going live and when we're uploading more videos, and like the videos if you like them. Tell other people about it, share them. Thank you very much, and see you next time, hopefully next week. Shane, next week another live.
Back to school next week. We might have to think of a topic though.
Okay, well, we'll see what happens, and
okay.
At some point we will be back. Thank you so much, Shane. It's so valuable.
It's a pleasure.
I'll see you next
time. It's 20 to 9 p.m. here, so good night, everyone.
Good morning here. It's 11:36 in England. I'm in Spain. It's 12:30. Whoops, hold on. Okay. Here we go. Thank you.